All right, so let's jump into this deep dive. And today we were talking data warehousing.
Okay.
And, our listeners already know a lot about databases,
Yeah.
tables, columns, keys, all that good stuff.
Mm-hmm.
But what happens when businesses need to, analyze huge amounts of data to make these big decisions?
Right.
That's where data warehouses come in.
Exactly. And that's what we're going to be unpacking today. And what's really interesting is that relational databases,
Yeah.
they're fantastic for everyday transactions, day-to-day stuff. But when it comes to the heavy lifting of, analyzing all that historical data that you have, that's where they fall short.
Okay.
So you can think of it like, the cash registers at the store.
Uh-huh.
Super efficient for ringing up each individual item, but not really designed for understanding, long-term patterns and trends.
So it's like needing a different tool for a different job.
Exactly. A data warehouse is built specifically to handle that.
Okay.
Those massive analytical tasks. So it's like a giant library
Right.
of all your business data all in one place, ready to be analyzed.
I see. So it's organized. It's ready to go.
Yes, very organized.
Okay. Okay, but why is that so important, though?
Right.
For businesses? I mean, can't they just, figure things out from their regular databases?
Well, it's not that easy. Imagine trying to understand, your customers' buying habits.
Yeah.
Over, let's say, several years, using data that's scattered across all these different systems.
Yeah, that would be a nightmare.
A complete nightmare. A data warehouse takes all that data, cleans it up, structures it in a way that makes it, super easy to analyze.
Okay.
And get to those aha moments.
I like the aha moments.
Yeah.
So it's about connecting the dots to see the bigger picture.
Absolutely. So let's say you're running, a retail business.
Mm-hmm.
A data warehouse can help you spot seasonal trends.
Okay.
Identify those products that are flying off the shelves, or even, understand how demographics impact buying behavior. These are insights you wouldn't really get just by looking at those, individual transactions.
Makes sense.
In your day-to-day systems.
So it sounds like this ability to analyze all that historical data could really help businesses make better decisions.
Oh, absolutely. Because what they did in the past will inform what they need to do in the future.
Right.
For example, a data warehouse can help a business optimize its inventory.
Right.
By analyzing, past sales data.
Right.
They can anticipate demand for certain products, during certain times of the year.
Yeah.
Which means that they can ensure that they have enough stock without, overspending on storage.
That's a really good example.
Yeah.
It seems like a data warehouse can really help businesses be more efficient and profitable.
For sure. And this actually brings us to a key distinction in the world of data, and that's OLAP versus OLTP.
Okay.
Data warehouses are built using OLP architecture, so that's online analytical processing, which is very different from the OLTP design. So that's online transaction processing that you usually see in relational databases.
Okay, so we got OLP, we've got OLTP.
Yeah, a lot of acronyms.
Some serious acronyms there. Can you break that down for us, like in plain English?
Sure. So think of OLTP like a busy airport.
Okay.
You've got hundreds of flights, taking off, landing every day.
Yeah.
It's all about processing those transactions very quickly and efficiently.
So speed and accuracy are really important.
Exactly. Now imagine you have, an aviation analyst.
Okay.
And they want to study flight patterns and passenger trends over several years.
Mm-hmm.
They're not going to be looking at individual flights.
Right.
They need a different type of data organized for that type of analysis, and that's where OLAP comes in. It's all about analyzing the data to extract meaningful insights.
Okay.
So, figuring out what the busiest routes are, peak travel times, or popular destinations.
So OLAP's like taking a step back, looking at that big picture.
Exactly.
Analyzing those trends and patterns.
Yes.
Whereas OLTP is all about handling those individual transactions, in real time.
Precisely. And data warehouses with their OLAP architecture are specifically designed to handle those complex analytical queries on really massive data sets.
Okay, that makes sense.
Yeah.
I'm starting to see how this all fits together.
Yeah.
We talk about why data warehouses are important, how they help businesses, and how their design is different from those, relational databases we're so used to.
Right.
But I keep hearing this term dimensional modeling
Yeah.
in the context of data warehousing.
Yeah.
What exactly is that?
So dimensional modeling is that secret ingredient that makes data warehouses really effective for analysis. So imagine a giant warehouse just filled with boxes of information. Without a good system to organize all those boxes, finding anything would be a nightmare.
Could be chaos.
Complete chaos. And that's what dimensional modeling prevents. So it's like creating a system of labels and categories for those boxes so you can easily find what you need. It's all about structuring the data in a way that makes sense for analysis.
So it's about adding context and relationships to all that raw data.
Exactly. So instead of just seeing numbers, dimensional modeling helps you understand what those numbers represent and how they relate to each other. It's like the difference between looking at, a list of ingredients and having a recipe that shows you how to combine them into a delicious meal.
I like that analogy. So dimensional modeling helps us make sense of the data and get to those insights that we need.
Yeah.
Can you give us like a concrete example of how it works?
Of course. So let's say we're analyzing, sales data for a clothing store. Our data warehouse might have a sales fact table. And that would contain, the date of each sale, the product ID, the store ID, and the sales amount.
So that table is telling us what was sold, when, and where.
Exactly, but it's just raw data. This is where dimensional modeling comes in to add some depth. We create separate dimension tables that provide more context about the data in that fact table. So, for instance, we might have a product dimension table that lists all the products sold in the store. And along with that, you'll have their categories, their brands, their prices.
So instead of just seeing a product ID, I can see the actual name of the product, its category, and other information that's relevant.
Precisely. And it just makes it much easier to understand.
It does. So
you can also have dimension tables for store information, like location size and store type. And then we can also have one for time with details about the day, the week, the month, and the year of each sale.
So we can really slice and dice that data in so many ways.
Exactly.
We can analyze sales by product category, by store location, by time of year.
Yeah.
So many possibilities.
That's the power of dimensional modeling. It lets you analyze data from multiple angles, and that gives you a much richer understanding of your business.
I'm really starting to see how powerful this is and how it can help businesses, really dig deep into their data.
Absolutely. And that's just the beginning. There's so much more to explore when it comes to data warehousing and the insights it can unlock.
So let's dive a little deeper, shall we?
Let's do it. And, this is really just scratching the surface. Dimensional modeling can help us uncover all those hidden relationships in our data, allow us to really analyze sales trends, customer behavior, any kind of business process with a lot of depth.
This is really making me rethink how I look at data. It's not just numbers on a spreadsheet anymore. It's like a story waiting to be told.
Exactly. And that's what makes dimensional modeling so crucial for data warehousing. It's the foundation for all those, insightful reports, dashboards, and analyses that help businesses make those smarter decisions.
So speaking of making sense of data, how do we handle those situations where the data changes over time? Like what happens if a customer moves to a new address? Or a product gets assigned to a different category? Wouldn't that mess up our carefully crafted dimensional model?
That's a great question. And it brings us to this concept of slowly changing dimensions. Or SCDs. As the name suggests, these techniques help us manage those gradual changes in our data so our data warehouse stays accurate and reflects the latest information.
SCDs, it sounds like a clever way to keep things tidy.
It is.
But how do these techniques actually work?
So let's think about our clothing store example again. Let's say a product, a particular style of shirt gets moved from the casual wear category to the formal wear category.
So the product category has changed. How do we handle that in our dimensional model?
So one approach is to simply, update the product category in the product dimension table. This is what we call a type 1 SCD, where we basically overwrite the old information with the new information.
That sounds pretty straightforward. But wouldn't we lose the historical record of the product being in the casual wear category?
You're absolutely right. And that's where type 2 SCDs come in. So instead of overwriting that original record, we create a new record for the product with the updated category and a new effective date.
So we have two records for the same product. one showing it in the casual wear category, and then one in the formal wear category, each with its own time period.
Exactly.
It's like having a timeline for each product, showing how its attributes have changed over time.
That's a great way to put it. And this way we can preserve the historical accuracy of our data. We can see that the shirt was in casual wear until a certain date and then moved to formal wear.
Right.
This is really valuable for, analyzing trends over time.
It prevents us from making those, apples to oranges comparisons if we're looking at data across, different time periods.
Precisely. And there are other types of SCDs as well.
Okay.
For example, type 3 SCDs add a new attribute to store the previous value.
Okay.
So in our shirt example, we could add a previous category attribute to that product dimension table, which would store casual wear.
So with type 3, we can see both the current and previous values in the same record.
Yeah.
It's like a before and after snapshot.
Exactly. And then you have type 4, which creates, separate mini dimensions to handle rapidly changing attributes.
Rapidly changing attributes. Those sound like a headache?
Right.
What kind of data would fall into that category?
So think about things like customer preferences or product pricing. Those can change pretty frequently, and using type 4 SCDs helps us manage those changes without cluttering up our main dimension tables.
So it's like having a dedicated space for those data elements that are constantly changing, keeping our core dimensional model a bit more stable.
Yeah.
So SCDs are all about managing change and making sure that our data warehouse remains accurate and reflects the latest information.
Exactly.
Even as the business grows and evolves.
You've got it. Implementing the right SCD strategy is crucial for maintaining that data integrity and making sure that our analysis is based on reliable and up-to-date information.
It sounds really important.
It is.
SCDs definitely seem like an essential part of the data warehousing toolkit. But before we move on, I'm curious how we get all this data into the data warehouse in the first place. We've been talking about having all this data from all these different sources, sales records, inventory levels, customer interactions. How do we bring all of that together?
That's where the crucial process of data integration comes in. It's like building those pipelines that channel data from all these different sources into our data warehouse.
It sounds like a complex process, especially when we're dealing with, different data formats and structures.
It can be quite the challenge. Imagine, trying to connect pipes of different sizes and materials. It's not easy.
Yeah.
That's why data integration requires, a carefully planned approach. We need to understand where our data is coming from, what format it's in, and how we're going to transform it to fit into our dimensional model.
So it's not just about moving data.
No.
It's about making sure the data is consistent and, usable once it reaches the data warehouse.
Exactly. A big part of data integration is data transformation. This is where we clean up the data, fix any errors, and restructure it to match the schema of our data warehouse.
There's like preparing those different ingredients before we can combine them into a dish.
Exactly.
We need to wash, chop, season them to make sure they all blend well together.
Yeah.
What kind of transformations do we typically perform during data integration?
So it can range from simple things like converting data types. For example, changing a date from text format to a date format, to more complex operations like splitting or merging columns, applying calculations, or even standardizing values based on, business rules.
It sounds like a really meticulous process that requires a good understanding of both the data and the business logic.
It does. Data integration is often an iterative process where we test and refine our transformation rules, to make sure that we're getting the data into the right shape for analysis.
I can imagine the data quality is super important during this process.
It is.
If we're bringing in data from all these different sources, how do we ensure that it's accurate and reliable?
That's a critical point. Data quality is essential for any data warehousing project. If we're working with inaccurate or inconsistent data, our analysis is going to be flawed and our insights are going to be unreliable.
Right. It's like trying to build a house on a shaky foundation.
Exactly.
It's just not going to work.
It's not.
So how do we ensure data quality during that integration process?
So we need to establish, clear data quality rules and validation checks.
Okay.
This could involve things like checking for missing values, identifying outliers or inconsistencies, and enforcing data type constraints.
So it's like having a quality control checkpoint at each stage of the integration process.
Yes.
We want to catch those errors or inconsistencies early on before they contaminate the data warehouse.
Precisely. And we can also apply data cleansing techniques to address any issues that we find.
Okay.
So this might involve, correcting typos, standardizing formats, or even using external data sources to enrich our data.
Data cleansing. It sounds like a vital part of keeping our data warehouse clean and healthy.
It's essential for maintaining the integrity of our data and ensuring that we can, you know, trust the insights that we derive from it.
Right.
But remember, data quality is not a one-time effort. It's an ongoing process.
So it's not just about cleaning up the data as we bring it in.
Right.
We need to have systems in place to monitor data quality over time.
When we need to establish data quality monitoring and governance processes to ensure that our data remains accurate, consistent, and relevant as the business changes and grows.
It sounds like a lot of work.
Yeah.
But it's clearly worth it if we want to make informed decisions based on reliable data.
Absolutely.
Yeah, data quality really sounds like the foundation for, everything else we do with the data warehouse.
Absolutely.
Because what good is all this data if we can't trust it?
Exactly.
Yeah.
You're right. Having, a well-structured data warehouse with clean and reliable data, that's a great first step.
Right.
But it's only part of the story. The real magic happens when we start using that data to gain insights and make better decisions, and that's where business intelligence, or BI, comes in.
Okay. Business intelligence, BI.
Yeah.
It sounds like a powerful tool, but what does it actually involve?
So think of BI as like the bridge between our data warehouse and the people who need that information to make decisions.
Okay.
It's about using tools and techniques to analyze the data, visualize trends, and generate reports that help businesses understand what's happening and what actions they might need to take.
So it's like taking all that raw data and turning it into something actionable.
Exactly. Imagine a business owner looking at their sales figures for the past year. Raw data alone might not tell them that much. But with BI tools, they can see trends, they can identify their best-selling products, understand seasonal patterns, and so much more.
Wow.
It gives them the insights they need to make strategic decisions about things like inventory marketing, even staffing.
So we're talking, we talked about structuring the data, making sure it's clean and accurate. And now we're talking about actually using it to answer these business questions.
Right.
What are some of the common ways businesses use BI?
So one of the most common applications is reporting.
Okay.
BI reporting tools let us create these structured reports that present data in a clear and organized way.
Yeah.
And these reports can be as simple or as complex as needed, from basic summaries to in-depth analysis.
So we could have a report that shows overall sales figures for the month.
Yeah.
Or a report that breaks down sales by product category, by region, even by individual salespeople.
Exactly.
It's about giving the right information to the right people.
Exactly. And then we have dashboards, which are like visual summaries of key metrics.
Okay.
And they use, charts, graphs, and other visuals to make it easy to spot trends and patterns.
I've seen those before. They look really cool.
Yeah, they can be pretty slick, and they're becoming increasingly popular because they make it so easy to monitor the health of the business. A well-designed dashboard can show you at a glance whether sales are up or down, if inventory levels are healthy, or if customer satisfaction is trending in the right direction.
That's really valuable for, busy decision makers who need to stay on top of things.
Right.
But what about those situations where you need to do more than just monitor what's happened in the past?
Okay.
What if we want to try to, anticipate future trends or predict customer behavior?
That's where things get really interesting. BI also encompasses techniques like data mining and predictive modeling.
Okay.
Data mining is about using sophisticated algorithms to sift through, mountains of data and uncover hidden patterns or relationships.
So it's like having a digital detective.
Yeah.
To spot those clues that we might miss.
That's a great analogy. And once we've identified those patterns, we can use predictive modeling to forecast future outcomes.
Okay.
This could be anything from, predicting next month's sales figures to identifying customers who are likely to churn or products that are likely to become popular.
Wow, that's powerful stuff. It sounds like BI is really about using data to gain a competitive edge.
It is. In today's data-driven world, businesses that can effectively leverage their data have a significant advantage. They can make more informed decisions, optimize their operations, and ultimately achieve greater success.
This deep dive into data warehousing and business intelligence has been truly eye-opening. It's clear that data is no longer just a byproduct of doing business.
Right.
It's a valuable asset that can drive growth and innovation.
I couldn't agree more. And the best part is that the tools and technologies for data warehousing and BI are constantly evolving, making it easier than ever for businesses of all sizes to really harness the power of their data.
This has been a really incredible journey through the world of data warehousing.
It has.
We started with the basics, explored the importance of, structure and quality, and finished by seeing how it all comes together to empower businesses with these, data-driven insights.
And for those of you who are just, starting your data journey, remember the key is to start simple, learn as you go, and never stop exploring the incredible potential that data holds.
Yeah, who knows, you might uncover the next game-changing insight for your business.
Exactly.
That's a great note to end on. Thanks for joining us on this deep dive into data warehousing.
Thanks for having me.